My name is Suzy Moat, and this is my colleague, Tobias Price. So my background's a mixture of computer science and psychology, and Tobias is a mixture of physics and finance. And at the same time, right now, we're faculty fellows here at the Turing Institute. But back at Warwick, where we work the rest of the time, Tobias and I are associate professors of behavioural science and finance. So we have one foot in the world of the social sciences and another foot in the world, or the broader discipline of data science. So, in terms of home department, this gives us a slightly unusual background in comparison to many others here at the Turing Institute. But we would argue that this is an area where there is massive opportunity. So I'm sure I don't need to point out to all of you that increasingly everything we're doing as humans is generating data. So just by using our mobile phones, by taking a ride on the tube, by buying something in the supermarket, all of it leaves these digital traces behind. And that means that in the social sciences, we've entered a phase where we suddenly have the potential to measure behaviour at a global scale, much more rapidly than we could before, at much lower cost than we could before, and potentially have the opportunity to measure behaviours that we simply couldn't capture before now. So, we are not the only people who are excited about this. So there's a whole field of computational social science, or social data science, as we've called it at the Turing Institute for today. And so we've got the task of trying to give you a whistle-stop tour of what's been happening in this area over the next 3 hours. So I hear that many of you have sat through a number of 3-hour sessions so far. I've got to say I'm incredibly impressed. I'm not sure I fancy my chances of making it the whole way through 3 hours. But so with that in mind, we're going to try and make it a bit easier for you today. So firstly, we're going to have a couple of breaks of 10 minutes. So do feel free to approach us during the breaks and ask us any questions that you've got. And secondly, while we've tried to mix it up a little bit by having 2 of us here, we've also brought along some virtual friends to whom we are very grateful and to whom we'll introduce you as we go along. Okay, but so to get started, perhaps I will just give you an example of one of the earliest pieces of work that Tobias and I did together to give you a sense of the kinds of things that we were excited about. So I'm going to start with data from Google. So what really drew us in with data on what people are searching for on the internet was its sheer global scale. So never before have we had an opportunity to measure what people are looking for, what information people are interested in on that sort of international scale. But there are some challenges if you want to use text data on a global scale. And that's the fact that people tend to search for things and communicate in different languages. So you can imagine that people in Germany might be searching in German, people in the UK might be searching in English. And so this can make it pretty difficult to compare what people are interested in different countries. So, luckily, one day, Tobias and I and our collaborators, Stephen Bishop and Jean Stanley, we had a moment of inspiration, and we realised that there was one thing that was reasonably universal between languages, and that's the year in Arabic numerals. So you can think of 2016, 2017, 2015, for example. So what we did is we considered Google data from 45 countries around the world that we knew had more than 5 million internet users. And we worked out for each of these countries how often they'd searched for the next year and how often they'd searched for the previous year. So this was using data all the way back from 2010. So the next year was 2011, the previous year was 2009. And what you can see on this map is that countries coloured in blue were searching more for the next year, 2011, whereas countries coloured in red were searching more for the previous year, 2009. Now, if you look at that map, you might recognise some kind of pattern. So, for example, some of the countries that are coloured in blue, like Germany, are countries where we know that on a global scale, their citizens are reasonably well off. Whereas there are other countries that are coloured in red, where we know that, again, globally speaking, wealth is not so high with these citizens. So we were interested in trying to understand whether there was really a relationship between what people were searching for online and economic well-being of these different countries. So we created what we called a future orientation index. So for each of these countries, we divided how often we found that people in that country had searched for the next year, 2011, and we divided that by the number of searches that we saw for the previous year, 2009. And we called that a future orientation index. And we found that if we compared that to per capita GDP, indeed, people who lived in countries with a higher per capita GDP were searching for more information about the future. So there's a number of reasons this might be the case. So a strong interpretation would be that this lined up with behaviours we've seen in psychological experiments, for example. So perhaps being in a better state of economic well-being frees up cognitive capacity to think about the future, or perhaps the other way around, focusing on the future leaves you in a better economic state of mind. Or perhaps on the other side, what we're seeing here is simply that citizens in countries with a higher per capita GDP are gradually relying more and more on the internet to make decisions about what they're going to do in the future. And so we've picked up that information-seeking behaviour as part of their decision-making processes with this metric. Now, the fact that you might be able to pick that up is something that has underlined a whole stream of research where people have begun to start to try and understand if we can use data from the internet to better understand and potentially predict economic decisions that people are going to make in the real world.
Suzy has set the scene, and we want to have a closer look of what she actually was starting to talk about. So she has presented you with one early example where data on what people are searching for online was to some extent usefully used in a scientific framework. So what is this data looking like? Can we get access to it? And the simple short answer is yes, all of all of us can actually get access to this data via the URL trends.google.com. Google Trends, a system which captures on an ongoing basis how often people over time have searched for particular search terms. So as Suzy emphasized, these new forms of data, online data, is actually something which is global. So this tool reflects that. So you can basically dig into search behavior in individual countries. It goes back originally on a weekly basis to the year 2004. So that's the earliest possible time for which you can look into search patterns. And originally weekly means that subsequently Google extended that service. And nowadays It actually, so over time, daily information has been added, and nowadays, if you look into that website, you even find minute-by-minute information on what people are searching for. Maybe crucially, to anticipate a question relating to that, it is actually data which is normalized to a maximum. So basically, Google presents you with this volume time series on the basis on an integer scale, starting at 0, ending at 100. To some extent, making it a little bit more difficult to decode how many actual people have searched for a particular search term, obviously for all sorts of reasons, in competition with other search engines. So to some extent, that is sensible information, but also if you think from a privacy point of view, if there are only a few searches for a particular search term, then obviously this is something which makes sense. You can filter search terms according to categories. So Google is working out, using all sorts of background information, possibly what you have searched on before, what you have searched for afterwards, what you might have clicked on in between. And so there are actually possibilities to distinguish terms. If you think of some famous examples, I mean, you want to work out how often people search for the term apple. All right, okay. Might be one thing, might be actually something other. And to, in particular, separating categories like a fruit from something which is technology is something which allows you the tool in terms of applying certain categories. You can get data for entire categories and so on and so forth. And obviously, you can get this information out of the system by downloading it as a CSV file. So that's roughly, in a nutshell, what Google Trends is, what it gives you. But the question is, what can you actually do with it? So this section was entitled as economic behavior. And basically, a few years back, some people started to look into the possibility of using these indicators, these search time series, in order to measure something in the real world a little bit quicker than we would otherwise be able to measure this behavior. So Suzy highlighted this basically very fast nature of these search behaviors. So basically one of these examples is this one we would like to share with you today, and that's a paper by Choi and Varian, where Varian nowadays is chief economist at Google. And what these two scientists did is actually looking into the possibility of predicting behavior, but not predicting the future, predicting, as it says there, predicting the present. So why is this important? So basically, I try to hint towards this already. So there are some things in the real world we don't know yet, despite the fact they happened already. So all sorts of indicators which offices for national statistics, for example, are gathering, usually come with a certain delay. So they need to aggregate information, they need to process, filter this information. At some point, they're putting together an aggregated index, and as soon as this information is released, then this information is basically reflecting a state of the world a few weeks ago, or maybe even a few months ago, or in some cases it might even take a year or more, in order to publicize the information reflecting the world, the state of the world at an earlier stage. So what Helen Varian did a few years ago is basically trying to incorporate how often people search online relating to certain different categories. And let's look at one of these categories which they analyzed now. And this is the number of car sales as captured by an index, which is basically the result of a survey. It's motor vehicles and parts in the United States. And this survey is sent out to dealers, and they need to respond to this survey. And usually it takes 2 weeks for this information to come in, and in order to publicize not only the final figure, but there's a certain additional complication actually to release preliminary figures. And then at some point you might have final numbers. And you can imagine for any kind of decision making, whether this is at a governmental level or at a commercial level, decision makers want to have the best possible information in order to make their decisions. And so in this industry, the number of vehicles sold across the entire industry, is obviously an indicator. If you would have a better measure, an earlier indicator for what is going on right now, then this might be something which could be extremely valuable. So what they did, they basically used one of these Google Trends time series, not on an individual search term, but an entire category, so relating to car production and sales, and basically compared it with the underlying time series. And they basically, what they used in a given month, they used the first week of searches generated relating to these topics. And this was then used as an indicator for how many cars or vehicles and parts have been purchased during this time period. So basically they compared it with a very simple baseline model. They just built a very simplistic autoregressive model, just taking into account the previous time step. And then they compared what happens if they add to this external information. So in that case, external information was how often people search for related topics and search terms on Google. What they find, and that's something you can see already here, so they compared then the mean absolute error of their models for this indicator, and they found that there is an improvement. So there's an overall improvement for that in-sample estimation, but crucially also a stronger improvement during the period of recession, where obviously there is a lot more uncertainty in order to get a clearer idea of what is going on in the entire economy during such time periods. Helen Varian looked also at other examples. Another very interesting one we would like to show you today is basically looking into travel behavior. So they were able to get hold of data from the Hong Kong Tourism Board, and this tourism board publishes on a monthly basis summary statistics on how many people are traveling to Hong Kong from different origins, different destinations around the world, the countries. And for 9 of these countries, they looked into the question. So I told you before, on Google Trends, you can filter search volume according to categories, but also according to countries. So they looked at Hong Kong related information. So as soon as someone searched for, let's say, restaurants or other related Hong Kong related information, or hotels, for example, then this becomes part of what Google digs out as this category. And this is information then filtered down to one of these 9 different countries, and then using this information in a similar fashion, and they found a very close match between how often people search for this information and how many people then arriving in Hong Kong and basically being recorded or surveyed as part of the Tourism Board survey. So these were examples where basically the measurement of economic behavior in a society, in a country, can actually be enriched, or this process can be accelerated when incorporating what all of us basically are producing when using Google as a search engine or any other search engine, obviously, if you're able to get hold of these data sets. But this type of approach wasn't actually the first in history where information which turned out to be delayed, or just as part of the process is delayed, can be basically enriched by something like search volume. And this brings us to our second topic, and this is actually measuring in terms of measuring the current health in a country. So many of you, let me ask you, so who knows Google Flu Trends? Who has heard of that? Right, okay. So then I only have to briefly explain the background to this. So this is actually one of the most famous examples where people started to incorporate search volume into measuring the current state of society. So this dates back to 2009 when this paper was published in Nature, where Google engineers, together with with members of the Centers for Disease Control in Atlanta in the US, asked one key question. And this question was, can search data tell us anything about how many people have the flu, are ill, and possibly are searching for flu symptoms? What they did, they had basically this red time series, so they had the actual number of people, or the fraction or the proportion of people being ill in the US on a weekly basis. And they used this in order to dig out all possible search terms which show a similar behavior. So they ranked this according to correlation, and basically the surprising fact in this first paper was that the most correlated search terms turned out to be related to disease, turned out to be symptoms of having the flu. And so the striking idea was born that this might actually be a way in order to set up a real-time monitoring system for any kind of current societal behavior, but in this case, crucially, for the number of people being ill. So what is the advantage of that? So like in this other example where information is delayed, the CDC information is also delayed. So the Centers for Disease Control are asking a network of doctors all over the US on a weekly basis how many influenza-like illness patients they have seen. And they are reporting back, this information gets aggregated, and so on and so forth. And when the CDC is able to release a figure on the weekly number of influenza cases, then this number is 2 weeks old. So it takes them 2 weeks to have this information in place. And obviously, if you need to act on this information, if you reach a certain critical level of proportion in terms of illnesses in a country, then obviously at some point you might want to consider to close down airport links or whatever might be suitable. But crucially, you want to have the best possible information to make possibly very difficult decisions. And this is reflected here, right? I mean, by using the most correlated search terms, they are able to come up with a model which is taking into account surges which happened in this 2 weeks period. So basically allowing us to look into the time difference between the latest officially announced data point and actually what might be going on afterwards. So far, and many of you know that service, it was a success story. It sounds really good, right? I mean, they basically created this as a service, rolled it out not only in the US, but also other countries in the world. Health agencies around the globe started to use this information until, as also many of you will recall, until actually this service got it quite wrong. In fact, they overestimated the number of influenza cases almost by a factor of 2 during the winter 2012-2013. So what has happened? I mean, many people afterwards described this in many different ways. There are all sorts of possible reasons for that. The most quoted reason was actually that during this winter, 2012-2013, a new stem of the flu, H1N1, occurred, and triggered by, or possibly triggered by, a number of media reports, news reports around the globe, people started to search for symptoms without being ill. And obviously this is catastrophic for a system which you have set up before and where you assumed, oh, this correlation we observed back in 2009, oh, that's something which will work forever. That's something we can use. And obviously as soon as you change the parameters, as soon as the proportion of people searching for something is not longer reflecting the proportion you assumed to be ill or affected, then this is something which doesn't work so well anymore. And crucially, there are all sorts of other reasons people added to this. I mean, obviously the search engine algorithm is changing over time. The information on the start page in terms of little small info boxes telling you something about individual diseases and so on and so forth is changing over time. The way how humans interact with the internet is also crucially changing over a period of more than 10 years. If you think of how many different devices we are using today, and so on and so forth. So the question was, is this actually the end of this story? I mean, is it actually the case that we can't reliably use this information at all because there are so many biases and crucially dynamic biases over time, which makes it really complicated or even impossible to use this information? And a number of people in different countries, including colleagues of ours, Alessandro Respignani, and colleagues at Northeastern University, but also Suzy and I, we started to look into this and were wondering, can we actually fix this problem to some extent? I mean, okay, we know that this static correlation in the past, which we observed in the past, is not necessarily the key. So we actually have to dynamically adapt in one or the other way in order to be able to still reliably measure or enhance our measurements by using Google data. And the second question was, I mean, they just use the correlation, they just use search data, but if you think about it, we also have additional information about this system in question available. And this is data on how many people have been ill, not necessarily now, but 2 weeks ago, right? I mean, at every given point in time, we have the information about 2 weeks before. It's delayed, but we can still use it in a model which we might want to build, similar to what actually Choi and Varian have done by using an autoregressive model and taking into account the past period's value, whether this is weekly or monthly. So it turns out that actually if we build a REMA model, basically taking into account features of the time series of how many people have been ill or are ill on a weekly basis, and then actually add to this Google data, then the question is, how much are we doing better, or are we doing significantly better at all? So that's one part of the question, but coming back to the first point, so the dynamic or adaptive aspect. So given that we can very likely assume that due to human nature and our behavior changing over time by so many different external forces, behavior is changing, we actually were wondering what happens if we introduce a dynamic framework where we basically readjust or relearn basically in every given time period, in every week, the proportion of people searching for symptoms compared to how many people are actually ill over or in this running time window. And by doing this, basically dynamically adjusting for external effects like news reports in this particular period when a new stem of the flu occurred. So if we do both of this, incorporate this dynamic fashion but also use historic information, then we are actually able to show that we can significantly reduce the forecast error compared to a baseline model which just uses features of the time series of influenza cases alone. And this significant reduction is between 16 and 53%. The range is due to the fact that obviously you can think of different window sizes. I mean, you can make this window longer or shorter in terms of how are you relearning this relationship between what is going on online and how many people are being affected.
All right, so we've talked quite a bit about online data so far, but certainly in the area of health, there's all sorts of other data that we're now generating that give us potential to measure health in a way we couldn't before. So there's wearable devices, but there's even just your mobile phone. So to give you some insights into what might be possible in this area, we have invited a friend, Paul Lukovic from DFKI in Germany, and he's going to give you a brief introduction to what we might be able to sense from mobile phones and wearable technology.
So today you can really buy apps that look at things like how many steps you do and that follow how much you would jump on your snowboard, and things that look at your location and tell you who is around you. But that's just a small part of what sensors, what mobile devices can really know about what you're doing. motion sensors can tell you not about how much you walk, but where you walk, up the stairs, down the stairs, on the rough street, in the mountains, and whenever. And there's a lot of work to tell you exactly where you're going. And you can, of course, do tracking, not just with GPS, but Google and other people can track you indoors. And there are maps that are being built of buildings, so they know exactly where you go in the mall and where you go in the university and so on. And there's more. So a lot of work we did was at using what you call audio scene recognition. And as everybody knows, if you close your eyes and just listen, you very often know where you are. And you can show that with this microphone that you have with a smartphone, and even without a recording continuous audio stream, which can be a problem for privacy reasons, but just small snippets, you can really detect things like a busy street, a football stadium, a church, a street. And you can also detect what people are doing, things like washing your hands in the bathroom, making a coffee, lawn mowing. Nearly everything you do, or a lot of stuff you do, leave a sound signature. And you can show, we've done this work actually quite a while ago, that you can very, very nicely recognize what people are doing just from the sound stream on a phone with a high accuracy. And there's more you can do. That's one of our favorite papers a long time ago, but it's still cool. So we're looking at trying to monitor nutrition. It's actually from many aspects in health an interesting problem. Can you see how much and what people are eating? And it's not very easy to do. You can do that by inserting electrodes into your throat and stuff like this, which doesn't have a big public appeal. But what we did, we put a microphone in a person's ear. And you know that you can hear yourself chewing. And by actually looking at this microphone, you can really count how many chews people are taking. And you can recognize with reasonable accuracy, if you're just eating chips or apple or meat or whatever. Again, personal experience, you can hear that as well. You can take that further. You can, looking at the stuff of microphone, you can follow the course, for example, of conversation by looking if it's you speaking or somewhere else. And also looking at smartphone sensors, you can go on, for example, look at who is in the room. So if I did a scan of Bluetooth IDs in this room, probably something like 30% of you would have their Bluetooth on because of your car speaker and stuff. And those are things that allow me to identify you personally. So it's really kind of interesting to see today there's this discussion about NSA and privacy and stuff. And you very see, I go in discussion with people about that, and then you see, they have their Bluetooth on, the Wi-Fi on, so they can be tracked, identified. People don't understand how easy it is to actually extract information about people. Other things that you can do, if you analyze, for example, the voice on the phone, you can really get very good information about people's emotional states, stress, and things like that. And again, those are things we did in different projects and shown to be quite accurate. So in summary, it's a small phone, but it's really a big brother. It's this thing can know a lot about you. And again, what you need to understand, the phone is just one device. One last example I wanted to give you of the complex things that you can do with the phone is we had a project with a psychiatric hospital at a diagnosis of what's called a bipolar disorder, which is this illness that you very often see with Hollywood stars when people go between mania and depression. And you can show that just using simple smartphone sensors, you can recognize with something like 95% accuracy on a daily basis if people are depressed or manic or normal. And we verify that in clinical studies. So again, that's just the phone. And what you're really seeing today is that we have an invasion of devices that are smart and sensor-enabled, and from Google Glass. And recently, I got myself a scale that connects to my iPhone and then gives me the data. Not that it helped anything, but it's just a feeling of doing something. And since it didn't help, I have the proof that I need more gadgets to do something. And that's the way you sell those things. So let me show you something you can do with other cool devices. So recently we started working with Google Glass, and essentially it's just a glass that has a camera, a small display, and a couple of sensors. One is the inertial measurement units, which essentially follows the motions of the head. And the other one is something very interesting. It's a blink sensor. It's an infrared LED that shines into your eyes and looks at the reflected energy. And that allows you to see if you blink your eye. What you can do with it is you can try to recognize activities. So here's a nice video of the blink detection, so that show you how did they work. And you can see here him wearing the Google Glass, and that's the output of the sensor. And the sensor has been conceived by Google to actually notice when you take the device off, so it can be switched off. But what happens is if you do small involuntary blinks, like everybody blinks involuntarily, you will see these blinks as small blips here. And what happens is people in psychology have found out that the frequency of your involuntary blinks depends on what you're doing. So if you're concentrated, you have a different frequency than when you're doing sports or something. So we did a study when we had people do a couple of activities such as reading and playing games or doing a maths problem or doing some home improvement work or just relaxing in front of the TV. And what you can show is that if you plot this for these activities, essentially the blink frequency, the mean blink frequency versus the variance of the essentially motions of your head from the acceleration sensor, they really separate pretty nicely. So the interesting thing is just by having something like a Google Glass, that there's a very simple diode looking in your eyes, you can detect what sort of complex activities people are doing with reasonably high accuracy. And again, that's just a commercial device, right? There are more stuff that you want to do. I just can't resist showing you one of our cool wearable stuff. So what we did is we devised something which is essentially a neck-worn touchpad. So in a piece of textile, here you have a conductive textile, and you wear it around the neck, and in a real device, you wouldn't have this stuff here. You would just have a normal collar. It doesn't have to be tight. It doesn't strangle you. All the students survived. And what you can do with it is you can look at you can essentially, if you look at simple physics, look inside your neck. So you can see, things that you're swallowing, things that are moving inside your neck. So that Jing Guang, that's the postdoc who actually did the project. And you can see the system detecting here chewing, swallowing, moving your head, and talking. And you can actually detect what a person is swallowing, whether it's a piece of bread or a piece of water. And again, it's something that you could put into your tie. Finally a good reason to wear a tie, because you know what you're eating, and give yourself a small electroshock if it's too much chocolate. And so you can see, we can classify things like shaking heads and swallowing and so on.
That's a little bit about health. But truth be told, if you're incredibly healthy, but you're not very happy, then life is still not so good. And happiness has been a pretty tricky issue for the social sciences over the years, because it's just so difficult to measure. It's something that matters to all of us, but it's subjective. And generally what people have needed to do to try and measure how happy people are has been to keep asking them. So to run surveys with all sorts of questions that you have to fill in that give some sort of indication of how happy you might be. This costs a fortune, it takes ages, and so that challenge in measuring how happy people are has put huge barriers in front of our ability to be able to understand what might affect people's happiness. Right, does anybody here work on sentiment analysis? Yeah, a few people. Okay, so just to give you a really basic introduction as to what you could do with online data, the simplest thing that you might be able to do in the area of so sentiment analysis, you're essentially trying to understand the sentiment or emotional content of some text normally. And so some people tried this with a huge corpus of data from Twitter. So doing the simplest possible thing, just looking at all of the words that people had typed into tweets and comparing them to a list that some psychologists made a long time ago called LIWC. And on that list, words are rated in terms of how positive they are. So are they related to positive emotions? And they're also rated in terms of how related they are to negative emotions. So in psychology, we tend to separate these two things, so how positive and how negative something is, to capture the fact that maybe something just doesn't have a huge emotional value at all. So if you do that, you work out how positive and how negative words are with Twitter data, then you see some reasonably interesting patterns, which kind of confirm what we might have expected. So if you look at the top to start with, this is measurements of positive effect from Twitter data. On the x-axis, you're moving through the day, so from midnight to the next day's midnight. And in gold and silver, you've got weekend days, and in other colours, you've got Monday to Friday. And essentially what you can see is that gold and silver, so the weekend days, are rating much higher than the weekdays, as you might have expected, with the exception of purple, which you basically see shoot off towards the end of the day as people cheer up as it gets to the end of the work week. And similarly, you see people seem to be quite happy around the time that they wake up, and then they're forced to go to work, and positive effect falls into the floor, and then eventually as it gets towards the end of the day, they cheer up again. And you see it's not quite the same with negative effect reflecting the idea that these two things are different, but you see some related patterns. This is yeah, you can come back to that, we'll give you a link to it. So that's a very, very quick introduction to what you might want to do with online data. But again, there's some really exciting things you can do with phones. And I'm going to stop there, and I'm going to hand over to another colleague, George McCarran, who we're very happy to collaborate with, Januki, who's here, and Tobias and I. And he's going to tell you about his project, Mappiness.
There are several kinds of happiness, and I won't go into that in a lot of detail, but the previous approaches at national or individual level tend to look at either evaluative happiness, which is a sort of a general, give me a number from 1 to 10 that represents your satisfaction with life as a whole. In fact, that's what they tend to look at. There are other happiness concepts. The eudaimonic happiness concept is about sort of how much you feel there's meaning and purpose and worthwhileness in what you do. And then the third concept, and the concept that we kind of need to use here, if we're looking at individual moments, is the more hedonic or affective concept, which is about your current feelings, essentially, your current emotions, your current feelings, because those are the things that we can sensibly ask about several times a day, right? Those are the things that kind of move up and down. If we asked you how satisfied you were with your life several times a day, you'd give us a few very similar answers, and then you'd get fed up and not answer anymore, because the answers wouldn't change a lot. Studies that look at people's momentary experiences, people's momentary feelings in that way have been done before. In fact, they've been done since at least the 70s. And psychologists call it the experience sampling method. In medicine, they call it ecological momentary assessment, where ecological is sort of the same as in ecological validity rather than nice natural environments. In the past, people have handed out notebooks or PDAs. They've beeped people at random moments, and they've asked about the experience and the context of that experience. And one thing they find actually when they check this is that sometimes even a majority of people's answers are falsified when you do it with the old technology. A large number of people fill in all the answers at the beginning of the study or at the end of the study when they send it back. So this has been done before, but it hasn't been done for the environment. I want to have a point to make before that. Why is ESM nice? We don't get any recall bias, so you ask people how they're feeling right now, and in principle that should be kind of accessible to them right now without a lot of kind of evaluation, weighting, summing, and so on. So it should be accurate, it should be detailed, and also we get panel data. So we can use fixed effects, we can take out all the within-person variation, we don't get confounded by unobserved individual level characteristics, how people use a response scale, personality types, and so on. And we can also make sure that we're not being confounded by certain kinds of people being found in certain environments because we're using only the within-person variation. This hasn't been done before. So this was during my PhD, and this is the iPhone launched at this period. And iPhone's a sort of perfect tool for taking this experience sampling method and applying it a bit more broadly. As these pictures tell us, it's got GPS, as we know. It's got a microphone for sound. We can send data back. We can make it go bing. We can present a short survey. We can take pictures. Millions of people have these already. And so that was this idea behind Mappiness. Now, you might spot that there's a big problem with using phones, and other people have alluded to this in their talks, which is, iPhone owners are on average young, rich, educated, and possibly self-satisfied, and they have to self-select into the study too. And then once they've self-selected into the study, they have to be able and willing to respond to each beep. So sampling is a big problem. It's probably the number one drawback of this approach. And again, you can grill me on that later if you want. But let's for now just say that I'm probably just in long here on the right, and I want to take part in the study. So I can download the app for free from the App Store, and that's still true. So if anyone wants to take part in Mappiness, I won't think you're rude if you start looking at your phones now. Search for Mappiness in the App Store. Once I've downloaded it, I spend less than 5 minutes sort of agreeing to some privacy and terms and conditions. I answer a few demographic questions. I confirm how often I'm going to be beeped. And then twice a day, I get beeped, much like getting a text. And I respond on a variety of questions. And so I say how happy, how relaxed, and how awake I am. I'm just going to talk about the happy responses here. I think I'm imagining I'm in a pub at the moment, so I'm going to be socialising and drinking alcohol. And even Andy, with his professed attention span of a goldfish, might manage to do a survey of this sort, because it really only does take 20 seconds. And while I'm answering, the GPS is getting my location, and all my data is being sent back. And I can look at some of the data as a sort of a reward. I can see some very simple aggregates. I can also download all my data if I'm in that kind of quantitative self kind of mood, and see it in various kinds of forms. I actually think that one of the most valuable things for people is just to be asked regularly, and they kind of develop an intuitive sense of when they're happy and what they spend time doing and so on. I can then download the data. I can see it on a map. I can subscribe to it in iCal and so on. That's going to show me that now. So we can see where I've taken pictures. I think this is a slightly self-referential slide. I can also look on the public website to see how people are happy, how people are feeling in general right now, and how they've been feeling over the past week, both across the whole country and in London. And I can see the public map, which shows us where people have been feeling happy lately. The project got some really good media coverage, and that was really useful for recruiting a lot of people, which was my main worry with this. I'd get a couple of dozen people giving me a couple of dozen responses, but that didn't turn out to be a problem. This was less useful than it might have been, because it was a UK study, and Le Figaro is a big newspaper, but it's not in the UK. But it's still very big news at drive time on the radio and in papers, that Tuesday is ever so slightly more depressing than Monday, even after we've controlled for bank holidays. So lots of news coverage, and that means that we, as of now, have over 3.5 million responses from 60,000 people. This is a map of the number of responses that we had, I think, within only the first month. And it's a logarithmic scale, so light grey is really rather few, but dark black is a lot. And so we have reasonable geographical coverage. This looks somewhat like a population density map. It shouldn't look exactly like a population density map, because it's where people are, not where they live. But this is pretty good. This is this is some descriptive data, which actually recalls one of the charts that we saw earlier today. But this is a whole year's worth of average happiness data for mappiness users in the UK. And we have all the days of the year, I think from the 1st of September to the 31st of August, 2010 to 2011, are kind of each horizontal line. And then going from the left to the right, we go from 8 a.m. at the morning to 10 p.m. at night. That's the period where by default we beat people, so we have plenty of data. And you can get a whole lot of things from the patterns here. So firstly, it's sort of stripy, and that's because people like weekends a lot more than they like weekdays. So the light colours are happier, the dark colours are less happy. And the stripiness tells us that weekends are good. The two particularly bright stripes are Christmas Day, and generally the Christmas holidays, and also the April-May bank holidays. At some point here there was a royal wedding, I think, which is a particularly bright spot, annoyingly for Republicans. And you can also see that the colour gets gradually lighter towards the right as well. Most people are not morning people. On average, happiness sort of climbs throughout the day.
To try and round off the kind of section that we started in the previous block, we'd given you some examples of how we might be able to use these new data sources to measure behaviour more quickly than we could before, to measure things that we couldn't measure before, that we had a lot of hypotheses about. So, for example, how happy people are in green spaces, but where we didn't really have the evidence we might want to have. We're going to give you one final example before changing direction a little of something we can now measure where you essentially find that people don't quite do what you thought they did. And so this is an example in the urban domain. And for this final example, we're going to get Ed Manley to talk you through it.
How do people route through the city? How does it actually work? We've got these studies that make certain suggestions, but they're sort of fairly limited in some respects, usually conducted in a virtual environment or only with sort of a handful of students. Can we get better insight by looking at bigger data sets, should they be available? And ultimately, do people really take the shortest path, or is it more complicated than that? So I was fortunate enough to get hold of a big data set of GPS traces from minicabs. Addison Lee minicabs in London, and they gave me about 700,000 routes of their minicabs, which I then worked out the routes for, and conducted a number of analyses. So the plan was to go through a number of things. First off, look at the accuracy of the shortest path assumption. So looking at whether people do take shortest paths, whether they do optimize their behavior, whether they are regularly traveling along the least distance path, the least time path. In view of those results, and I'll give you a little bit of a insight here, they don't do that, right? So obviously I went on to the next point, which is how do individuals' personal preferences and perceptions influence route choice? And then moved on to looking at how urban form influences route choice, which again, these both align with sort of some stuff in the literature saying that people do have varying choices. We know that from our own experience, and that the urban form does influence how we choose a route through the city. Okay, so first tests were, do people take the least distance path or any kind of shortest path? I basically ran a load of different optimizing algorithms and compared them against every single route. Simple as that. For every origin destination route I observed, I modeled another route, be it distance, free flow time, congested travel time, angular deviation, that's sort of space syntax style thing, fewest turns, and combinations of them all. So basically what happens is that none of them perform very well. We get about a 40% match, well, the highest is about 40%, which is for where you're minimizing your distance and trying to travel on big roads, so A roads and motorways. We get about 40% match there, but it does drop down to 17% when we're looking at deviation from the target, which is a strange one. So overall, what we see is that if we try and model a route as a complete journey from origin destination, modeling, that's just a single decision-making process, we find it doesn't work very well. So we can't really say with any particular confidence that people minimize distance as a singular objective, right? Is everyone convinced? Well, fine, whatever. Numbers speak for themselves, so. Right, so what I moved on to then was looking at, well, if there's no single optimizing model producing a very satisfactory solution, is it because people are doing lots of different things, and how do these preferences and these sort of behaviors vary? So what I did was break up the data set rather than dealing with everything and trying to work out a single rule for every single route in the whole 700,000 routes. Look at some very distinct pairs, because what the bigger data sets allow you to do is to break down break down your data into very smaller parts to get insight in particular circumstances. So what I did was take a couple of origin destination pairs, which would be between two fairly sizable regions, far apart, requiring them to travel across central London. So with a lot of alternative routes, and a lot of potential for variation. And instead of going for a sort of single value that would sort of provide an indication of how well these of what's going on, I've used mapping. So like Mike says, we use maps, we use pictures to sort of understand the world in our game. So what I did was map up these routes between particular origin destination pairs and see what just view what the variation is. So here's the first one. You can see that okay. This is between Southwest 11 region and Northwest 1 in London. Yeah, it's about 500 journeys, and what we see is a big split between the traffic. We get about 46% of the travellers going up along the south bank of the Thames. We get 27% going up along Hyde Park and Euston Road, but no real single route being the sort of sole attractor of all the traffic. So there's a big variation in decision making there. Taking another one, this is North 1 to SW1, about 900 journeys. And we're seeing again a split of the traffic, two broadly main routes, so one going along the river again, one going up through central London. But yeah, there's a lot of variation too, lots of other routes going on at the same time. So this demonstrates that there is a variation in behaviour, but we still don't really know what the basis for that variation is. We know that there's no sort of single route which people are taking, but what we wanted to do was understand a bit more about the underlying causes and the underlying sort of decision making that would be shaping the route choice behaviour. And for this, I wanted to turn towards urban space and the role of urban space in influencing these choices. So there's a couple of things to think about here were the role of particular locations. Well, so considering that we see that there is a difference from optimal routes, we want to look at where those differences were. So what's causing the deviation away from a shortest path, and identify the types of features in London that would be influencing these route choices. So taking this first one, what I've done here is look at just the pure differences between the actual journeys from west to east London and a set of model journeys using least distance path for each origin and destination between the same origin destinations. So for every single journey, we've got an alternative least distance path. And what we see are particular locations coming up as being much more attractive to real drivers rather than ones which be assumed to be taking the shortest path. So places along the river, for example, along Euston Road, which is along the top of central London, up there. Yeah. And along the parks again. So these are really salient locations, long straight roads, big straight roads that are being much more attractive to real drivers. If we were assuming that everyone was taking the shortest path, then everyone would be going through central London along that route there, a very straight road, but quite congested. So we can look at also again if we're people optimizing their travel time, and again we're seeing similar features in on the road network being pulled out as more attractive to real drivers than those which are simulated.
All right. So, predicting human behavior. What might we actually be able to predict, and will we be able to succeed? So, the area we wanted to look at is actually even a very complicated one. It's a very competitive one. We wanted to look at economic decision making, and in particular in the area of the stock markets. So why did we decide to do that? I mean, if you think about how all of this came together in terms of social data science and how we as humans are generating data, then obviously at some point, in particular, the financial domain started to produce lots of data, electronically recorded, easily accessible, some of them even freely available. And this happened in the 1990s when a lot of stock exchanges turned into electronic trading platforms. So very soon, I mean obviously also fueled by the developments around high-frequency trading, a lot of data has been produced, decisions to buy or sell certain stocks, your decision to buy an X amount of a particular stock, let's say, I don't know, Microsoft or Apple or any other stock in the market, your order being routed to your broker, then routed to the central exchange place, and then being executed there. Actually filling a huge database of actions, decisions which humans and or machines made to buy or sell certain assets. So what we were wondering was whether we can actually get a different angle, a different stream of information when incorporating a completely different source of data. And for this, we actually turned back to a data set we introduced to you before. And this is what people and how often people are searching for specific search terms online. So does this have anything to do what is going on in the markets? In order to answer that question, we designed a hypothetical trading strategy together with a colleague of ours, H. Eugene Stanley from Boston University. And this very simple strategy works as follows. So we are looking up from Google, in the same way we have explained before, the search volume time series for a particular search term. We will tell you in a minute which terms we looked at. And we basically did this on a weekly time scale. So at that point in time, actually this was the most reliable information which Google allowed us to access. And we compared search volume in the current week with search volume which we have experienced before. In this simple example, but obviously this can be extended in many different ways. So to make it simple, let's look at the search volume for the past 3 weeks. And we were interested in the question whether more or less people or searches, number of searches, have been generated in the current week T. And then in our hypothetical trading framework, we had to make a decision. So we will come back to that. So basically what we decided to do is, if search volume for a particular search term decreased in the current week, then we triggered a buy transaction. We bought a stock or an index or another asset in the coming week, week T plus 1, and we executed that buy order at closing price on the following Monday in order to make sure that there is no overlap between the signal we are getting from Google. So Google, weekly Google data was at that point in time updated between Saturday and Sunday Pacific time. And then we used it in order to execute our decision on Monday at closing price, and we kept that position for exactly 1 week. Obviously, we made a profit if the market went up during that time period, and vice versa. The search volume can go down, then obviously also the opposite can happen, so more people are searching in week T for this specific keyword. In that case, coming from the assumption or hypothesis that basically an increased level of searches might actually be something people are concerned about something, and then this might trigger searches for a particular keyword. And so our assumption was that, okay, let's assume for more searches we actually link this to the decision to sell the underlying stock or market. And for this particular example, we used the Dow Jones Industrial Average as one of the major benchmark indices in the world. So what would have happened if we would have executed this strategy over time from 2004? I mentioned it before, so this is the earliest possible time for which you can get hold of Google data, and when we execute this mechanism on a weekly basis. So if we use just a random keyword, so this was one of the keywords we looked at, culture, how often people, geographically restricted, how often people in the US have Googled for the term culture, using this as an input for this trading strategy in order to execute our decisions on a weekly basis, then we actually get, as a result, this blue curve showing the cumulative profit and loss of this strategy over time. One very simple conclusion already. I mean, you can see here over time, blue ends up with 5%. You would have ended up with 5% more than you started with. Obviously something not many of you would be very excited about, I hope, in particular given that a lot of time is involved, the number of years, but obviously also a lot of risk would have been part of your investment experience, so to say. Obviously during the financial market crisis, during the years 2008 in particular, you would have actually seen lots of fluctuations in your investment. So it's also from another angle not a very interesting strategy. If you compare it to a very, very simple benchmark baseline strategy, so to say, so this is shown here in red, then this makes even less sense. So there you basically just buy at the beginning of the period, the so-called buy and hold strategy, and you would stay invested over this entire time period. You would have ended up with 16%, which is even slightly more, but also not hopefully something you would be extremely excited about. And crucially, both these curves stay more or less between this band of plus minus 1 standard deviations here on the slide indicated with black black dashed lines. So this was one of the words we looked at, I mentioned before. And there were other words. In total, actually 98 different keywords we looked at. And another one was how often people in the US have Googled for the term debt. And obviously, you can see here that this slightly changes the picture. So you would have ended up with a little bit more, crucially something like 2 to 3 standard deviations above what you would expected when just investing randomly. And the question is whether this reveals anything to us. And the short answer is actually it doesn't, because you could immediately raise the concern. So you showed us culture, now you showed us debt. I mean, maybe this was the best performing keyword out of these 98 different keywords which you have shown us. And this would be cherry picking, right? I mean, it would be just by chance you would find one of these terms which is actually performing reasonably well. And I would answer to that, I would need to respond that actually, in fact, this is the best performing keyword. So we can't actually make any conclusions based on the results of the term debt. So let's go a little bit further. So this was culture and debt, but we looked at 98 different keywords I mentioned before. And when we plot them according to performance during this time period, then we wondered whether we can actually try and explain some of the variance we find in this sample of 98 different keywords. So as a side comment, this sample of 98 keywords has actually been produced in a way that we used a tool which is called Google Sets, which Google in the meanwhile retired. It's basically a tool which gives you back semantically related keywords if you start with 1 or 2 or 3 and so on and so forth. If you start with the term Dow Jones and NASDAQ, it might give you back S&P 500. If you put in gold, silver, it might give you another metal. So basically, it allowed us to make up some of this topical space by financially related keywords. And we included also random keywords like culture, garden, train, restaurant, and so on and so forth. So we wanted to ask the question, what makes maybe a keyword successful? And when looking at this distribution, we were wondering, is it maybe the case that more financially related keywords tended to be on the left-hand side of this histogram? So we wanted to explore this, wanted to look at this a little bit further. And for that reason, we created an index which we called financial relevance. We needed to measure it in one or the other way. And the way we decided to move forward is actually counting how often individual keywords were used in the full text issues of the Financial Times as an issue, as an outlet which actually writes about financial news. Of course, the Financial Times is also written in English, so it wouldn't be enough just using the count of terms in the Financial Times, because a word like and or the, so just frequently used English words, would produce a very high count. So we normalized it by the fact how often these terms are used in English language. And one proxy for that, which we used, was how many pages Google can find which include that term. So the short answer is that this financial relevance indicator turned out to be significantly correlated with our returns. In other words, the more financially related a keyword is, the more successful it was in this hypothetical, historical analysis. So we were wondering whether we actually might be able to pick up or investigate this kind of relationship a little bit further. So far, this is just a simple correlation across a number of years, including the financial market crisis. And we were wondering, can we actually pull this into pieces? Can we actually separate out, for example, just the positive part of the strategy from the negative one? The short answer is yes, this actually doesn't make a difference. Both of these strategies are individually successful. What happens in individual years? The short answer is, for many years, this also was a significant relationship. But crucially, can we also find different data sets where we might be able to pick up that signal? And Google is one source of information, which we are able to use for that. Another one is Wikipedia. So most of you know that Wikipedia exists, and possibly you are using it on a more or less constant basis. For us, the crucial advantage is that Wikipedia makes data freely available, how all of us are using Wikipedia. So we were able to use hourly information on article views for all different pages, making up the English version of this encyclopedia. And we tried to replicate what we did in the first part of the analysis. So we basically looked up a category, financial topics, a self-organized way in which Wikipedia is clustering and putting together different pages, so around 200 to 300 pages. And basically we aggregated on a weekly basis how many views these pages have received. And we used this as an input for exactly the same strategy. If there were more searches for a financially related topic page, then we sold at the beginning of the coming week and vice versa. And basically what you can see is here is that the blue distribution seems to be shifted towards the right. So it's basically, instead of looking at individual keywords, we are now looking at the distribution of different topics and words. And the median of this distribution is significantly different from 0 and positive, of course. And this is interesting because actually it replicates the finding which we have seen in Google data before, so that the more financially related a content or a keyword was, the more successful it was in this historic analysis. So one of our co-authors, Chester Curme, now actually Dr. Chester Curme, wondered, Wikipedia does not only give us information about how often people are accessing individual articles, but also how often or when an individual has edited a certain page. And so he actually started to extract the information, so basically aggregated all the timestamps when these pages have been changed over time. And we aggregated on a weekly basis the information and used this as an input for the strategy. The short answer is red is not significantly different, the median is not significantly different from 0. So the number of changes to pages doesn't seem to make a difference. That was interesting. We thought, okay, if there are significant company-related events, it might actually be reflected in people changing Wikipedia articles. One possible explanation for this might be that actually we find lots of zeros in these entries. So a number of these articles are not edited for a long time over this time period. And so this might be the reason why we actually see this very pronounced peak around 0. So, at some point we were wondering, can we just stick any kind of Google data or Wikipedia data into this approach, into this algorithm? It would be scary, right? Something must be wrong with this algorithm if this constantly and continuously produces abnormal returns. So we decided to just test this algorithm by inputting another completely different category, which has nothing to do with markets, or at least shouldn't have do anything with market behavior. And this was a category on actors and filmmakers. Luckily, the number of page views for George Clooney and others doesn't seem to have any relationship with what is going on in the markets 1 week later. So this distribution is not distinguishably different from random trading, just flipping a coin week to week. So we were wondering, okay, so we got some evidence from Google data, we got some evidence from Wikipedia data. Can we do this a little bit more systematically? Obviously there are lots of different approaches to cluster the topical space of something like Wikipedia. And this might actually be an advantage in answering how content relates, or which content crucially relates to what is going on in the markets the week later. So together with Chester Curme again, we basically used an approach from computational linguistics, LDA, in order to create our own topics, basically to make up from all Wikipedia pages of the English version of Wikipedia our categories of different topics. And then what we wanted to do, we wanted to use every single individual category as an input for this trading strategy and see which kind of information is actually the one which might actually have something to do with what is going on in the markets the week later. So obviously the first step was to use LDA, but then when we ended up with all these different 50-something, 55 groups of different topics, then the question was, I mean, how do we refer to them? How do we label them? I mean, obviously, Suzy and I and our collaborators on that paper, we didn't want to influence the result. I mean, we didn't want to stick one label to an individual category. And so what we did in terms of making this as objectively as possible was to present these groups of keywords to people who had nothing to do with the study in question. And the best way to do that was actually to turn to Amazon MTurk and basically pay MTurkers to label these categories, to come up with a title basically for all these different groups of words. And that's the way how, for example, the term politics was proposed. This was the majority of MTurkers actually reading through this list of different keywords, and the same for business. What did we see? If we look through all these different topics, then we find that only 2 of them produced significantly different or significantly positive results. And the next question was, I mean, obviously now you can argue, okay, I mean, it's the same thing as with the 98 different keywords, right? I mean, maybe it's just the best performing one, and obviously there's a certain chance that 2 of these categories turn out to be positive. So obviously what we did, we corrected for the fact that we tested all these different categories, using excuse me, using a correction method. So basically, after this correction method, only 2 of them survived and turned out to be significantly positive. If we look into one of these baskets now, if we look into this business basket, and that's published as supplementary information, we actually find that these terms are more or less similar to the group of financially related keywords we had before. So this was basically confirming our initial results, but we were very surprised to see that also a second category, politics, turned out to be positive. And after thinking a while, I mean, obviously, if you think about it now, I mean, politics, it's not necessarily crazy to assume that this is disconnected from what is going on in the markets. Usually we refer to the financial market crisis and basically Washington, London, and other major places in the world needing to make decisions about how, for example, to save and rescue the financial industry. But obviously this year has shown with a lot of political events that obviously politics can have a lot of influence on how markets decide to move in subsequent weeks or months. One final note on that is actually you spot that this is called Politics 1. And you might wonder, why is this labeled as the first politics category? So Amazon MTurkers categorized or labeled 3 different categories as politics. And then we actually stick the numbers 1, 2, and 3 to it. So why is that? I mean, why do we have 3 different categories in the first place? I mean, obviously there must be something wrong with the LDA, right? So if you look through the individual search terms making up these categories, then you find that one category is related to general national politics in the US. There was a second one more related to state-level politics. And there was a third one, politics made in Westminster. And LDA well separated all these 3 different issues. And we labeled them with 1, 2, 3. It turns out that actually national US-based politics is politics 1, which is here shown as positive related with subsequent market moves. We did some experiments, for example, replacing the US-based stock market index by the FTSE 100, the benchmark index here in the UK. And actually, Politics 1 doesn't do so well anymore. So basically, the UK-based version of politics, particular relating to articles about Westminster-based politics, tended to be more successful. So what do we learn out of all of this? I mean, obviously we're not claiming that this is something you can start to use tomorrow. I mean, in particular, given that we published these search terms, I mean, obviously this is something which is out there, and markets tend to absorb information which is interesting and obviously abnormal, and this will remove patterns. But this is not necessarily the crucial reason, despite the fact that after we published these studies, a number of banks and financial institutions turned to us and started to look into using online data in their decision-making algorithms. But crucially, it is also again, like in examples we have seen before, the human behavior, the human element, which is changing over time. I mean, if I go back to this slide, then it's obviously the case that today the world is not necessarily concerned, or most concerned, about the financial market debt crisis, which we have seen a number of years ago. Also, if you would have started at this point in time to use this strategy or keyword for your investment decisions, then you would basically have ended up with a more or less flat performance development over time. So the key question would have been how early on, how to identify this keyword, which later on is related to market behavior or is becoming related to market behavior. So basically, this is a kind of health warning, not to use this without any reflection. So basically, what you would need to do in order to implement this, and that's obviously the challenge which lies in that, is actually to find a way to dynamically include new and upcoming keywords which are becoming important to market behavior, and at the same time being able to remove from your basket or universe of different keywords or topics from whatever source information which is not longer relevant or interesting to market behavior.
Okay, so the stock market is quite an extreme example because, you know, as Tobias was explaining, whereas the rain doesn't get upset if we predict it's going to rain, it carries on and rains. You know, humans, if you tell them what you think they're going to do, have a bit of a bad habit of reacting to this. It doesn't work in all circumstances. I really wish I could stand outside Warwick and predict there was going to be a traffic jam at 5 o'clock and magically make it disappear, but to date it's not worked. But yeah, so there's a range of different kinds of reactions, and stock markets is definitely at the extreme end of that in terms of how likely people are to react to those predictions. But nevertheless, there are some other areas where people have tried to draw on online data to predict what people are going to do in the real world. And while this is of huge interest to us, let me give you some examples of things that other people have done. So this is a great paper by Sharad Girl et al. They're using data from Yahoo, and they find that if you look up the names of movies and you find how often people have searched for those movies on Yahoo, then you can actually use that data to try and anticipate what the box office revenue is going to be when the movies open. And they do this with a number of examples. So they look at video games as well. So they find that video games, if you look for data on people looking for the names of those video games, again on Yahoo, then you can use that, again, to anticipate how much revenue that video game is going to make when it comes out. So there's movies, video games, other examples. So the paper's interesting for two reasons. Firstly, because it's more examples of things that we can predict using information on what people are looking for on the internet. But it's also good because it's quite a critical paper. So for example, they find that while this video game result holds for video games where there wasn't a previous version of that video game. So if you think of something like Grand Theft Auto, you know, there's been loads of them, right? So the idea is that the very first one, which wasn't a sequel, the web data is useful. But once you've got a video game that is a sequel, the web data, they find, doesn't tell you anything above what the revenue of the previous version of that game would have told you. And this comes back to things that we were discussing with relation to the Google flu example. So it's really exciting what we might be able to predict using these new data sources. But we do need to really carefully reflect on what we would have already known from the data that we had before. So there's sometimes some use in having a completely different indicator. But in the majority of cases that we've looked at so far, the real value comes from combining these new data sources with the traditional data sources and finding the best possible way to do that. One last example, online data and predictions. Have to mention this. This is a paper by Taha Yasseri and colleagues. So Taha is a faculty fellow here at the Turing Institute, does loads of cool stuff with Wikipedia data and much more. But this was a paper that he and colleagues wrote where they showed that you could use data on how often people had been viewing pages about a particular movie and indeed editing those pages. And again, you could use that data to anticipate the revenue of the movies. So I mentioned before, we're going to give you the references to all of these papers afterwards. We'll put the slides online, or at least the Turing Institute will help us do this. But we'll also give you a document with a full set of references for all these papers. OK, so lots about online data, new sources of data. What can we measure that we couldn't measure before? And how might this help us better understand and predict human behaviour? But there's some important things that we can do with data sets that have been around for a little longer if we apply the right methodology. And so another area where we're obviously really keen to have the best possible understanding of what's going to happen in the future is diseases. So doctors have to make all sorts of decisions around scheduling non-urgent operations, around getting the vaccines they need in place, basically being best prepared and also reducing the risk of diseases. And the more they know about how these might spread, how bad the situation might be, the more useful actions they can take in the face of this challenge. So some really interesting work in this area has been done by a colleague of ours, Alex Vespignani at Northeastern University in Boston. So I'll just get him to tell you about some of that.
Scientific work, because we want to go into uncharted water. This is the sense of adventure. Humans are the carriers that transport diseases. Everything we touch provides an opportunity for the pathogen to spread from one person to another. Our daily interactions form the social network along which germs travel. But imagine if we could use that social network to predict the path of a virus before it travels around the globe. Then perhaps the germ you carry to get your morning coffee won't lead to an outbreak, because you'll know when to be ready for it. The way we can look at the world is we think in terms of networks now. Everything basically that we have built around us is a network. When you have such an awareness, you can really think about changing the world around you. One of the things that we really want to achieve is predictive power to track diseases and then develop models that allow us to forecast their evolution across the world. We integrate entire databases on human mobility, census data on where people live geographically located, and that's create a kind of synthetic world in the computer. From this synthetic world in the computer, we run numerical simulations that forecast what and how and when the epidemic will spread around the world. You have to hand out those forecasts and scenarios to policymakers, and then they have to factor many, many things. You can tell hospitals this is the time that you have to postpone anything that can be routinely postponed, and that intensive care units must be free because you might face a wave of sick people needing attention. We can all think back to the H1N1 epidemic of 2009. That was the first time we were in a position to do a real-time exercise. And what we were able to predict, according to our data, was that the flu was going to peak in October-November, which is about 4 months earlier than the flu usually peaks. We can do a validation of those results, and those results were mostly correct by the week. Now we can see that our computational models, the data that we integrate, and the knowledge that we have accumulated on the spreading of diseases is finally being recognized for achieving predictive powers. At this moment, what we have here at Northeastern is a concentration of the most prominent people in the field. This is where things are happening. And somehow, what I feel is that we are living in some kind of a revolution. So network science, data science, what we have at the moment is something that allows us to do incredible progress in an area that was not even possible to define 10 years ago. That's really like being in the right spot at the right time. It's amazing.
About some of that. So we've been talking a lot about using these new data sources to predict human behaviour. And that's because that's something we've been working on for quite a long time, as have other people. And so as part of this, in the past, Tobias and I worked on a project in the US where we were subjected to terrible experiences, like having to fly to Malibu every few months. It was awful. So we were working on a project with Alex, who you saw speak before, Alex Vespignani, our colleague Jean Stanley, David Lazar, who turned up at the end of that last video, and also Neil Johnson, and a number of other colleagues. And we were trying to work out to what extent we could use online data to predict a huge range of phenomena. So from stock market moves and other economic changes, to disease spreading, to election outcomes, and indeed to outbursts of civil unrest. So on the civil unrest front, we were very lucky to work with Neil Johnson, who used to be at the University of Oxford. Some of you might know him. So I will let him talk a little bit about his part of the project.
So Suzy mentioned, let me talk about the first, because Suzy mentioned that we were on this grant, we went to Malibu, etc. The point of the grant was the following. If you knew everything that was on the internet, and you knew about past events, etc., could you, in my case, for our particular case, could you say, could you predict future civil unrest events? Could you make a prediction that, in 7 days, people on the streets of Brazil are going to be out, in Sao Paulo, they're going to be out walking around because you sort of saw it coming. You saw it coming from the information. So we were tasked with that area in this grant. Every day we had to send off warnings of future events to the city level and also to the issue level. It had to be whether it was labour or it was housing related or education related. So these were very specific warnings sent in every day to the government. Government scored them. It came back whether you were right or wrong. And I have to say, when we first went into this, how, you think about it, civil unrest, you hear nothing on the news. Sao Paulo, suddenly Sao Paulo, there are events, and then there's nothing. Then it's on to the turtle that escaped from somebody's garden, and, the news has kind of moved on. So it comes in bursts. These events come in bursts. So we thought, like I think probably a lot of you think, maybe a lot of people in the literature were thinking, this is a contagion problem. So we busily went about building a contagion model. Something Suzy didn't mention, there were 3 teams we were competing. So the other teams went off and did what they were doing. They also built contagion-like models. And it turns out that civil unrest isn't a contagion process. And I want to show you and share with you what it actually turns out to be, or what we think it turns out to be. I mentioned the bursts. So you've got nothing, 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 nothing. This is time going this direction, nothing, nothing, bursts, burst of activity. This bit is like a contagion process. I'm not going to bother going through the detail of the model we came up. Suffice to say that a contagion model modified can explain the types of shapes of bursts that you get. In fact, we found a kind of universality in the shape. The bursts tend to be longer than a normal kind of contagion process. They have a longer tail. They can have recurrent peaks. And they also tend to have a very delayed onset. But, you know, more or less, you look across countries, you look across cities, all of Latin America we had to do, they classify, they fall down in these 3 classes, these 3 shapes that I've shown at the bottom. A very simple model that reproduces these 3 shapes is one where people, as individuals, are accessing some common space, which may be, you know, me switching on my phone and looking at some chat room. And in that time I have my phone and I'm looking, I'm susceptible to the information from it. And then I maybe, oh, crikey, there's something going on in 3 streets away, I'm going to go and get involved. I turn my phone off, I go over there, suddenly I'm out of that common space. And if you have people going in and out of this common space, it can give these 3 shapes. But that's not what I want to talk to you about, because I want to talk about, what about that dark part? What about before the burst? What is going on there? And the story of that turns out to be one, it's a good job we're in the business school, because it turns out to be something to do with innovation and also organizations. What we found is the following. This is a complicated chart. It's meant to be complicated. On the bottom, you see the horizontal line going to the right is the time series of civil unrest events. Now, 3 teams tried for 2 years to look at time series analysis to see if this burst that you see on the bottom right with that triangle, where that burst was coming. We tried every type of time series analysis we could think of, looking at previous events to try and predict the future. And for everything we and the other teams could do, this burst came out of nowhere. Just came out of nowhere. Until we started to think about, well, it's going to involve some kind of organization. And that was the key. So first of all, we were looking at contagion, we were looking at tweets. Tweets had nothing in them. They had something on the day and 2-day and 3-day time scale, but they didn't have this kind of month to year time scale in them. It turns out that Facebook had the answer. And it isn't Facebook individual accounts. If you try and, as you know, you've got Facebook accounts, you can set up a page on Facebook. And when you set up a page, you have the choice of organizations and causes. I mean, you can put all sorts of other things, you know, bakery, this or, but you can have organizations and causes. And people, what we found is that people were creating these pages, even though there may be 1 or 2 of them creating them, and people will collect and organize around these pages. These pages might come and go. They may have many likes and then people stop liking them. But it's that organizational development that we found to be the long-term build-up then to the tipping point of this burst. So on the top of this plot, in tiny, tiny print on the left, is the list of organizations whose pages appeared during a 2-year period prior to the major burst that was a year ago in Brazil. I'm just showing you Brazil. We had to do all the other countries as well. It's a similar story for the other countries. So you have a list of the organizations that appear. The red dot is where they appeared in time, their first activity. And what you could begin to see, even just visually, is that there's some kind of development as you get towards the right-hand side, and the right-hand side where the burst appears, then suddenly, you know, there's a large number of organizations. So what we're seeing is not a contagion process involving individuals just passing things on. It's people, maybe even a common pool of people, aggregating around certain causes and certain pages and then disappearing back and then forming again. It's like it's the typical kind of fission fusion social dynamics process, but now on the internet, and now behind these, in some sense, nameless organizations. So we found, in a minute I'll tell you what the order parameter is that we found for the transition, but let me give you a clue to so that we understand what's going on with this transition. It's not like a contagion process. It's not like contagion would be, I've got a bunch of sticks here. If this was a contagion process, the more I shake it, the more they each shake each other, and everybody transfers energy to everybody, and suddenly all these sticks are flying out. That would be a contagion process. But what you can see is if you steadily drive a system, you drive it in a reasonable way, not too fast, not too slow, what happens is very different. So you never thought you'd see an experiment here, but we're going to do, it's computational, but in the end, everything's experimental, right? So let's see what happens. These are, if you like, these could be memes, these could be ideas, these could be pages around which interest is waxing and waning. It's coming and going. So your sticks come up, see sticks come up, sticks come down. Let's see what comes out at the end. Does one issue come out? Do 20 issues come out? Well, it turns out that only one ever comes out. In fact, I don't know if anyone knows what these are. These are actually Buddhist prayer sticks. There's a whole reason that only one comes out. That's why they exist, because then you take it off to one side. There's a few Chinese characters on here, and you get them interpreted by an interpreter on the side in the temple when you go in with the sticks. So one only ever comes out. It's not like I've done it once and I got lucky this morning. So that's the type of transition we're seeing. We're seeing this transition where one issue is emerging from this sea of issues, not through contagion. Contagion would be a mess, entropy increases. This is more of a kind of ordering of the issue. And out comes the issue, out comes the day, bang, up comes the burst.
Neil was just talking about civil unrest. But let's think about a different kind of conflict and crime problem. So imagine there had just been a terrible disease outbreak. Alex Vespignani, unfortunately, had not predicted it in time to stop it taking out the entirety of your local police station. So everybody's gone at the local police station. Let's hope this never happens, but everybody's gone, and somehow they've got your number. And they say, right, well, I heard that you've been studying predicting human behaviour, and so you are going to have to be in charge. And so suddenly you find yourself in charge of the local police station. And you have to decide now where to put police cars and police people. Where are you going to put them? Any thoughts? Pubs. Okay, how come?
There's a correlation between football matches, beer and violence.
Okay, a true data scientist approach. Right, okay, yeah, good suggestion. Any other thoughts? Okay, well, I mean, John's picked up on something key here, right? We know that these are areas where crime has happened in the past, and so it would make sense, if you think about it, to try and put some resources in those areas to try and be there before the crime happens in the future. And this is an approach that the police have often taken in the past. So this is a map of Camden showing the distribution of a particular kind of crime. And so this is a map that I've heard referred to in technical terms as a blobby map before. And it's the kind of thing that would have historically been put on the wall and think, okay, the areas where we've seen lots of crime occur in the past, maybe that's where we should put our resources in the future so that we can be there to watch out for crimes possibly developing and stop them before they occur. So, there's some sense in this, that we do see crime persist in certain areas, as you see there. But we don't just know where crimes have occurred. If you consider the huge records that police forces gather when people report crimes to them, when they find them themselves, they don't just know where the crimes have occurred, but they know when they've occurred as well. And there was some really interesting work done just down the road from here at UCL by Kate Bowers, Shane Johnson and colleagues. where they found that that really matters when the crimes occurred. Indeed, what they saw was that if a burglary had occurred in a particular house on a particular street, then not only was the chance of that house being burgled in the near future much higher, so unfortunately lightning does strike twice, but indeed the chance that the other houses on that street would be burgled over the next 2 weeks was much higher than it would have normally been, and in particular for the first week. So the recency of the crime, as well as where it had occurred, turned out to be really, really important. And there's been a number of explanations suggested for this. So those of you, spent some time in the UK, as I'm guessing most people in this room have, you will have noticed we have a bit of a habit of building houses that look exactly the same next to each other. And so one of the theories is that once the burglars have worked their way round one house, well, firstly, if there was some stuff that they couldn't get the first time, they come back and get it, so they're kind of gathering it again. But secondly, if they've worked that house out, they've got an idea of how the house next door might look, and also a sense for other reasons of what those people might have. So you've probably got people in similar socioeconomic conditions living near to each other. And so the theory is that the burglars then go back to try and exploit that knowledge to gather more goods from those locations. Okay, so we've seen that crimes repeat themselves in particular locations. So certain locations are more subject to crimes than others, so pubs and football stadiums, like John's example. But we've also seen that if one bad event has occurred, then the chance that another event of that kind might occur soon nearby is much higher. And I know we've been talking about how people behave, but that pattern might remind you of something in the natural world as well. Any suggestions? I'll give you a clue. There was an example on the news today of a natural earthquakes. Exactly, right? So, if I ask you all, okay, where's the more likely to be an earthquake in the near future, San Francisco or London, then sadly you can all answer that, right? Well, I guess we're safe, but it's not so good for our friends in San Francisco. But at the same time, as we've unfortunately just seen in New Zealand, if the one earthquake hits, then it is quite likely that you'll see another hit nearby. And so there was some interesting work done by some people at UCLA, including Andrea Bertozzi, who came and gave a Turing lecture here, done some interesting work in this area, where they realized that they could take the mathematics that was being used to try and anticipate where earthquakes were going to occur, to instead anticipate where crimes were going to occur. So you'd have this kind of background event, and then in brown there, and then in red you'd see similar events cluster nearby. In blue, you see the same happen around the red events. And so this earthquake approach has been bundled into some software called Predictive that's been sold to a lot of police forces around the world, and is being used to try and anticipate where crimes might occur. So I'm not going to play this. There's a video. We'll have the slides. If you want to watch this video, it'll give you a brief introduction to that sort of approach. But I can also recommend that you might want to speak to Theo Damelos. So Theo is a faculty fellow here at the Turing Institute. He's done some great work with NYPD in the past, and he can tell you all about this and also some interesting algorithms that have developed since. What I am going to do, given that we're standing down the road from the birthplace of some of the most interesting approaches in this area, is pass you over to Toby Davis. So Toby will tell you again how networks might relate to this problem and help us anticipate where crimes might occur.
One thing that you'll notice about these figures is that they look a lot like figures from academic papers and not a lot like urban areas. and they're not particularly reflective of what's really happening. This is just a continuous 2D media with nothing much else going on. So our interest is really in incorporating realistic urban form and what that means for models like this, and in particular, the role of the street network in doing this. So why should we be interested in the street network and the effects coming from it? Well, firstly, in the case of something like burglary, for which it's particularly obvious, targets are arranged on the street network. So everything's got an address, that's where the targets are. Also, offenders move around the street network, so that's how they access their targets, and that's how they escape from them, for example. But thirdly, we have this idea where if we just think about risk moving through space, we get counterintuitive ideas about where risk should go. So just to take a playful example, here's just a piece of map that I cut out of Newcastle upon Tyne. And suppose we had a crime happening there. Any crime analyst in the classical British mould would draw a circle around that and say that's where crime's going to spread out. But if you do that, you'll send some police to the sea, and no burglaries happen in the sea, right? But even apart from that flippant example, if we have a crime happening there, say, if we draw a circle around that, then okay, that's more realistic in terms of what the urban area is like. But we have it diffusing over to this street there. So actually, that street, it's close in Euclidean sense to where the incident happened, but it's actually miles away if you actually want to travel there. You've got to go all the way around, literally round the houses, to get there. So why should risk communicate over that space? And indeed, it almost certainly doesn't. So to think about some of the theory of why that doesn't, here's a brief introduction to kind of environmental criminology and the theory of why these things matter. So crime pattern theory is a kind of the predominant theory of this kind of thing. And what that states is that if we're thinking about how offenders decide where to commit crimes, they commit crimes in places that they know or that they have awareness of. And the way that they gain awareness is during their daily activities, which may well be of a non-criminal nature. So it might be, so they have certain activity nodes, they're walking around, traveling between these nodes, and as they do that, they form an awareness space, which is the kind of places that they're familiar with and that they might have some idea about the criminal opportunities there. And of course, all of this is down roads. That's how people are moving around. And some of that is going to intersect where there are genuine opportunities for crime. So things where some sort of rational actor will think, yes, I will commit a crime here. So by thinking about where these awareness spaces happen, we can think about where people will tend to be aware of crime and where they will therefore offend. There's kind of this duality between awareness space and kind of criminal intensity. And aggregating this up across multiple offenders, the kind of obvious corollary of that is that places or streets that are in more people's awareness spaces, so that more people travel along habitually, will experience more crime. Okay. So we can easily start to think about analysing networks in these terms and see if we can get some results out of that. So it's trivial to represent a network, a street network as a graph. There are multiple ways to do it, but here I'll talk about what is known as the primal representation, where you simply place nodes at all of the junctions of the graph, so that's anywhere where there's a choice of route, and then connect up any two junctions where there's a street leading from one to the other. So that's just exactly the way that you would naively encode a graph. And what can we measure about things like this? Well, we can measure loads of stuff, but the most immediately obvious thing to think about, particularly given this kind of pattern theory idea, is betweenness. So thanks to Neil for teeing me up nicely by referring to that in his talk a minute ago. I'm going to patronise you slightly more by showing a video of how betweenness builds up on a street network like that. So the idea of betweenness, this may be tedious, but in case anyone doesn't know, the idea is that you take every possible pair of origins and destinations, find the shortest path through the network between those things, and every time a link features, so I'm talking about link betweenness here rather than node betweenness, for those who care. Every time a link features in a trip, you increment its score by 1, and the reddest link in the graph is the most between. And it's kind of picked out the most central there. There were quite a lot of people yesterday making the very good point that shortest paths aren't necessarily the best way to think about travel in an urban area. That's absolutely true, and I make no bones about that. This is just a first order way to kind of approximate these ideas. So if we draw betweenness for a realistic urban area, this is the city of Birmingham with street segments coloured according to betweenness. You can see on the right that it kind of picks out what you'd intuitively think were the busiest streets. And as a point of interest, this doesn't match up in any way sensibly with the Ordnance Survey classification, so the official classification of these roads. You get roads which are called major roads, and there's a huge variation in how you would estimate those to be used across their length, partly because they are very long, and a classification applies to an entire road rather than a street segment. So, does this have a relationship with crime? As much as there's a perverse appeal in setting up results which turn out not to exist, I wouldn't have brought you here if there wasn't something in this. So, this is looking at police calls for service in Camden. That is exactly what it says on the tin. It's where the police are dispatched according to 999 calls. And one method which was proposed for kind of looking at urban activity versus street network properties was following this paper by Porter et al., where the idea is simply to compute KDE surfaces of these two things and then look at the correlation between the two. So on the right is the KDE surface of betweenness, on the left it's the calls for service. The blotchy artifact is because of the nature of the data, and we have kind of done some work on re-scrambling that. Anyway. You can kind of identify some points of interest where it looks like there might be something in this. And indeed, when we do the correlation, these are relatively good, I would say, and they certainly tally up quite nicely with what's shown by this approach in the other context, which is of economic activity in cities, in the case of Bologna and Barcelona. So these are showing that betweenness is, in this case, quite a good predictor of these activities. On the other hand, we can look specifically at the street segments. So take street segments as the unit of analysis. And in this case, if this is taking all street segments of Birmingham, ordering them in increasing order of betweenness, and taking a moving average of burglary rate as we move through those. And there's a reasonably pleasing trend through that, where it's around about 40% more crime is happening at the more between end of the spectrum than at the lower end. And that all stands up with very large significance if you run proper statistical models on that as well.
So it's all very well being able to do these interesting things with these new data sets, maybe get some new insight into human behaviour. But we have been talking about data of various kinds which comes from humans. And that means it is absolutely essential that we do consider the ethical dimension of accessing, of analysing, and of acting on these data sources and the inferences we can make from them. Now, this is a big focus here at the Turing Institute. You can talk to people like Luciano Floridi a lot about this. We're just going to say a few words about obvious cases where this has come up recently. So hands up if you're on Twitter. A few of you. Okay. So if you found out that you'd been included in those Twitter results that I showed you before, would you be particularly upset?
Everyone minds it, so why?
Yeah. So nobody's particularly bothered. Okay. Hands up if you heard about the Facebook emotions study. Yeah? So a few of you know about this. So basically something completely different happened. So essentially what Facebook did, and some researchers at Facebook, is they analysed the things that people were posting to Facebook in a similar way to what we discussed with the Twitter data. So again, they were looking at things that people posted to Facebook, and they were working out how positive were the words that people had posted. So looking them up in this big list I mentioned before, LIWC, and pulling out for each word the positivity rating for that word, and doing the same for this negative dimension. So you take each word that people have posted on Facebook and you work out how positive is it, how negative is it. So then for every update that's posted, you can give it a positive rating and a negative rating. So you can look at the percentage of very positive words, percentage of very negative words. So on these graphs, going upwards at the top, you've got more positive words. Going downwards, you've got more negative words. Now, the thing is with Facebook, you can explicitly consider what people have posted themselves and what they've seen or what they will see other people post. Yeah? So on the y-axis, we're rating how positive the things were that a given person had posted. And then what's happening here on the x-axis is that Facebook manipulated what people saw in terms of how positive or negative it was. So for a certain subset of Facebook users, they removed the most negative posts. And for another subset, they removed the most positive posts. And they looked to see how that might influence what the users themselves posted. So you can see a control group here. Again, yeah, up at the top, more positive, down at the bottom is more negative. And basically what you see is if you take out the most negative words, then people start posting things which are more positive, and they stop posting things which are quite so negative. And similarly, if you take out the most positive words or posts that they would have seen, then people start posting things that are less positive, and they also post things which are more negative. So, as you know, some of you had heard about this study, and I'm guessing that you might have heard about it from the newspapers before you found it in a journal. So there was huge outcry around this. So similar analysis to Twitter, but what's the difference?
People feel they're being manipulated.
Right, okay. So the idea was that instead of just, I suppose, analysing what people had left behind, there was a sense of it actually being an experiment that people didn't feel that they'd agreed to be in. And so they said, oh, you know, you're manipulating my emotions. That was an outstanding question as to whether people's emotions were really manipulated, because again, we're just counting positive and negative words. You know, maybe we would have seen correlations for other reasons. But nevertheless, you know, Sheryl Sandberg had to apologise. You know, there was a huge outcry around this. Now, I'm glad that we have people trying to work out why these reactions occur here, because you could say this is kind of puzzling, because you know, Facebook is manipulating what we see all of the time, as are many other online services, often not just to change the percentage of positive or negative words that we post and then telling us about it openly in a public paper that everybody could access, but potentially, you know, companies are trying to get us to spend more money or to spend more time on their website. And you could argue that that's a bigger outcome, that's having more of an impact on you than you changing the percentage of positive words that you posted. But generally, if you tell people that, I guess they're kind of distracted by the fact that they were able to buy something quickly and get it sent to them quickly, and they don't react in the same way. So I think there's probably some interesting behavioural biases that you can see in this. And I think, but it is a very complex area where we clearly need new rules, new understanding of why people react the way they do, what people are genuinely happy for us to do, not least because there seems to be a mismatch between what people say they're happy with and what they then do. And it's all quite complicated. It's made more complicated by one last example we're going to give you, which is what you really can infer from what people leave behind. So the personal information that people leave behind on their posts on social networks such as Facebook. And for this, I'm going to hand over to Turing Greppel.
We really need a particular type of data set for that, and fortunately it exists. It's been collected by my colleagues at Cambridge University, and it's called My Personality. And it's a really powerful data set, probably the most interesting one I've come across in my career. And here you see the names of the people, again, who drove this. And it was generated by a Facebook app that has been running for over 6 years now, where people were given the opportunity to take certain psychometric tests, like a Big Five personality test or an IQ test and so on. And they were then asked if they would be willing to allow the app to take a snapshot of their Facebook profile. And so we have both the psychometric test results here for the participants, and we have, from their volunteered user profiles, their relationship status, age, gender, and other information, their Facebook likes, their friendship network, and so on and so forth, whatever you can get from Facebook. And it is this two-part data set and correlating these things that I will talk about in the rest of the talk. Okay, so here's an analysis that we ran on it. And first of all, you need to understand that we can represent this data as a matrix, the input data, if we just concentrate on the Facebook likes for people. So we have a set of users here, roughly 60,000 in this example, and then we have a set of what I call likables, things that you might or might not like on this axis here, and there's a sparse matrix that is 0 if that person didn't like that thing, and 1 if they liked it. Now, we need to understand that by that we just mean having pressed the like button on Facebook. It doesn't mean that they don't like things they haven't clicked. So that's a bit unwieldy to work with such a data set. So the first thing we do is we use singular value decomposition to reduce the dimensionality of this data set, essentially going from very high dimensional, 55,000 dimensional vectors describing each user here, to a dense representation where we just need 100 dense components in this space here. So we've basically compressed the data from this high dimensionality into this low dimensionality. And it turns out that we can do that while retaining a lot of the interesting signal. And then in step 3, we really used rather standard statistical methods like linear and logistic regression to try and build models from these Facebook likes to various variables that we're interested in, including things from the Facebook profile, the age, the gender, political and religious views, relationship status, and so on, but also from the test results, the Big Five personality, intelligence, satisfaction with life, and other things. So that's basically our experimental setup, and if you think in terms of this manifold metaphor, we go from this high dimensional space into a lower 100 dimensional manifold. It's still pretty high dimensional if I think about it. And then we're trying to find directions within that, and that's the regression step, that essentially correlate with intelligence, certain personality traits, and so on. That's what's happening here. I can't go into the details of the limitations of this study, but you surely understand that there's a lot of selection bias going on here. This is specifically computer users, Facebook users who are happy to take personality questionnaires. So it's not unlike the phenomenon of the weird people that are used in studies, which are basically psychology grad students. Okay. Let's look at some results, and we had the good fortune, or maybe not good fortune, that this work received a lot of coverage in the press, and so I'll let someone else do the interpretation here and then maybe talk a little bit through it.
Another one for big data. A University of Cambridge study analyzed what 58,000 US Facebook users said they liked and compared it to detailed profiles and personality tests that these users later took. And the result was surprisingly accurate estimates of race, age, political views, and even sexuality. Accuracy was lowest, about 60% when it came to predicting whether a user's parents were still together when they were 21. People whose parents divorced before they were 21 tended to like statements about relationships. Drug users were ID'd with about 65% accuracy, smokers with 73%, and drinkers with 70%. Sexual orientation was also easier to distinguish among men, 88% right there. For women, it was about 75%. Gender, by the way, race, religion, and political views were predicted with high accuracy as well. For instance, white versus black, 95%. Now, here's the key. The more you like something on Facebook, the easier you are to analyze. The correlation of someone's age to the model's prediction rises steadily as the number of likes to analyze increases as well. Ditto for gender. So keep in mind that just because you think you're not revealing a lot of personal details on Facebook, you're still spreading the word to the outside world as well as those online marketers. That is today's Off the Charts.
I don't know how she does it, but okay, so if we want to go through that a little more slowly, we looked at these binary variables, and in particular, you need to ask yourself what kind of measure of accuracy you use for this kind of thing. We used the area under the curve in particular because some of these attributes are very unbalanced. And so, for example, if you have a minority of people in one class and a majority of people in the other, then just predicting the majority class would give you a very low prediction error, but it wouldn't really reflect your ability to distinguish between these. And that's basically what the area under the curve type of measures address. What we see is that things like gender, the ethnic background, that these standard demographic traits are in fact relatively easy to predict here and can be predicted with high accuracy, which kind of confirms that those are interesting variables that have been used for a long time. She mentioned that these self-reported lesbian and gay variables, that it seems to be easier to predict here for men than for women. Interesting to see that things like political views and religious views can be predicted quite accurately, but I mean, this is not necessarily any kind of magic, right? In fact, it's guaranteed not to be magic. You know, if someone likes Obama, you know, it's not actually that hard to predict these things. So just to keep that in mind, right? Some of these signals can be fairly explicit, and then you have things like use of drugs, drinking alcohol, smoking cigarettes, and so on. We get some predictive signal here, but again, once you've figured out that someone is like a 12-year-old kid, then you know correlation carries you over that to that kind of insight. And then there were these interesting little signals about being in a relationship or not, or the question if the parents separated. Okay, and then we have these numeric variables. Prediction accuracy here was measured by the Pearson correlation. And here we have age, which is again a standard demographic and which can be predicted very well. And then we have these quantities associated with personality, and that's quite nice to see that we get a predictive signal here. In comparison, this is in some sense how the maximum accuracy you could have expected for these variables based on the inherent inaccuracy of the test. So these tests are also not perfect, and they have only some degree of internal consistency. And so these predictive methods reach roughly half of that potential maximum. And then similarly for intelligence and satisfaction with life. So interesting predictions can be made, but of course there's a lot of noise there as well. Okay, let's turn to something else.
The blockbuster revelation that people with many friends like Jennifer Lopez, while volunteers with few friends liked walking with your friend and randomly pushing them into someone or something. Hey, it's not their fault they don't have friends. Everyone they know keeps getting randomly pushed into traffic. But most importantly, the study revealed what your Facebook's likes say about how smart you are. Researchers found that high IQ corresponds to liking Mozart, science, and the Colbert Report. That's right. That's right. What can I say? That's right, folks. All right. Bless you. I am smart.
Okay, so two things about this. I hadn't realized this, but if you ever wanted exposure of your scientific work in the media, make the media part of your work. And they'll be happy to report, because that's their favorite thing, right? They create stars that they report upon them. The second thing is that the competition, The Daily Show, was also on the list for high intelligence. So now I would like to finish this part by just going through some of the likes that were associated with different attributes. And I don't want you to take this too seriously. I mean, what we took here, basically, we took the regression coefficients and look at the high ones and the low ones for the different attributes. And there are a lot of interesting network effects that may or may not invalidate some of this analysis. But it should be interesting anyway. So with intelligence, these likes are associated with high intelligence, and these are associated with low intelligence. And there's really some interesting stuff here. I mean, there is the Colbert Report and the Daily Show, science, as you might expect. The press just loved the fact that curly fries shows up here, and I leave it to you to believe if that is a valid signal or not. And then you have these really strange things like Morgan Freeman's voice. Is anyone here who likes Morgan Freeman's voice? Yeah, it's remarkable, isn't it? It's, I always found it to be absolutely fascinating. And then you, on this side, you have, that's always my problem at this point. I don't know any of these things. Well, actually, Harley-Davidson, I do know. And it was quite funny to see that when this was reported on, one of the local TV stations interviewed the Harley-Davidson dealer near Cambridge and asked what was going on and confronted them with these results. And he pointed out that a lot of Cambridge academics were his customers and that he was quite surprised as well. Let's look at some other dimensions, happiness. So this is the satisfied side, and this is the dissatisfied side. It looks quite strange if you know a little bit about American politics to find certain characters here. But there's an interesting thing here about, Pride and Prejudice, you know, that is quite nice, but about being conservative, being Christian, athletic stuff comes in. So it's not implausible, but always keep in mind that these things are effectively self-reported. So we have to take that with a grain of salt. And then here, the dissatisfied things, always a bit sad to see that science is among the things that is associated with a degree of dissatisfaction. And then, of course, our competitors' products, as you can see here. Let's look at another one, extroversion. This makes a lot of sense, I think. Things like dancing, socializing, I feel better tanned, you know, at cheerleading, and so on. And then here's the list of my hobbies. Programming, video games. Well, you know, what can I say? Okay, let's do one. Now this is it. So if you are able, have the power to make this type of prediction, then you need to think about how that impacts people's perception of privacy or right to privacy. And there was quite a lot of reporting, and some newspapers just said, oh, how funny, curly fries and Indiana Jones, and we can make these predictions here, Pride and Prejudice here. But of course, there were people who commented on potential privacy implications. And in fact, that was also the premise of the paper, to point out that these things are possible and potentially dangerous. So user privacy is definitely something to think about here. And I don't want to discuss this in detail, just a few questions. And one question, for example, is, are users aware to what degree we can make these predictions? And I think very few in this room would be surprised that these predictions can be made, but is that true for non-experts as well? If they were aware of it, would they be happy for us to make those predictions? Would they still make their data public so that we could infer these things? Or maybe the opposite is true. Maybe these predictions really just summarize what people are trying to project to the outside world anyway. I mean, maybe not low intelligence, but you know, some of the other dimensions. And finally, what we're of course struggling with is the question, if we can improve a service using these predictions, in how far is that a valid trade-off that we can make? Can we trade the user's privacy for improvement in service? What kind of communication between the company and the user needs to go on to make that a legitimate thing to do? And finally, there may be some technological ways of addressing this problem, but I don't have time to go into that.
In the short time we've had, we've managed to give you a bit of an overview of the kinds of data sources that people have been working with, what they've inferred with them, There's so much capacity to apply interesting data science methodology to these new data sets to really increase our understanding of human behaviour and to allow us to make better measurements and predictions that can be used in policy. If anybody's got any ideas or they're wondering if a methodology they work on might be useful in this area, then it's certainly something Tobias and I would be very happy to chat to you about. But otherwise, so I think the final two things I'll say is these videos, they came from so we were very happy to run Europe's first computational social science conference at the University of Warwick a year or so back, with much appreciated help from Marva and Janiki, who are here. So those, if you want to know more, those were excerpts from the talks. You can go to our Data Science Lab YouTube channel, and there's loads of it. So you can go and see even more talks around these topics if you'd like to hear more. And we will also, as I've said, give you a handout which summarizes, gives you references to the papers that we've touched on very briefly, points out some more. And if you'd like to know anything more about the area or other things you could read, then do just grab us at some point or send us an email. We'd be happy to chat. But so I think all that's left to say is thank you. You made it through 3 hours. It's been a pleasure talking to you all, and we will be happy to answer any questions at any point. Thanks a lot.